Alright, welcome back. Today we'll be doing our last written assignment of Unit 2 before we start our test, and it's a 5-block word analysis. Now last time we did a 5-block word analysis, you were provided with the answers. This time, I'm going to ask you to figure out the answers. And the way you find the answers is you get your note packet, and for Archimedes' principle, that is the law or principle you're being asked to analyze. So you go to the notes, Lesson 1, Archimedes' principle. The definition is given to you in the notes, so you would write the scientific definition right in there. The buoyant force. Okay, so it's a tight squeeze, but the buoyant force on an object in a fluid is equal to the weight of the fluid displaced by the object. That's the scientific definition. Now my description, I'd probably look and say, an easier way to think of that, I'd look at some of the other terms, is pretty much objects weigh less in water than they do in air. That's how I really think of it. So we'll write that right in. Okay, so I would describe this as objects weigh less in water than they do in air. Now for a drawing, it might be good to think back to the lab that we did. In the Archimedes Principle lab, we were weighing things underwater. So I'm just thinking of the idea that if an object's underwater, like let's say for example a golf ball, it's going to weigh less. And then also, a good way to illustrate that is if we have the golf ball in air, this weighs more. So I just write a little note, weighs more in air. Okay, 2 or 3 related words. Well, that's pretty easy. As we look at this, probably the most important related word is the buoyant force. So we probably put that in. You might want to take a look at the word displace. That's a very important word too. And that probably would work out pretty good. So now we have a pretty good analysis of Archimedes' principle. We have the book definition, the simple definition, a picture to help us remember that things weigh more in air than they do in water, and that displacement and buoyant force are really what it's all about. Use the same procedure to do Pascal's, Boyle's, Charles, and Bernoulli's. This will be due then on the day of the test.